Good morning, everyone. So let us start today with vernier calipers, and we will also be doing screw gauge today. Any doubts from yesterday's class? If no, please raise your hand. No doubts, everything is clear. Okay, fine. Okay, we proceed ahead. So least count. What is least count? As the name suggests, least count means the least measurement which can be taken from an instrument. Okay, so that is the least count. Like for an example, in this scale, if you see, from this side, we can draw like 1 millimeter. So 1 millimeter is the least count from this side. And this side, we can also draw 0.5 millimeter. Okay, because that many number of divisions are there, and this is 0.5 millimeter. So this is the least count from this side. If it is clear, please raise your hand. Good. So these are few instruments and their least counts. Now, error due to least count. So, if let us say we are asked, draw 26 millimeter, or let us say, we have been asked that this is a line. So, this is a line L26. So, now how to report this line? Okay. And what is the length of this line? So, we can see here that it is 26 millimeter. But the last one, you know, it can be, slightly more than 26, or it can also be slightly less than 26. We are sure that it is between 25 and 27, but we cannot tell that it's exactly 26 or not. So, therefore, how do we write it, or how do we report it as? This is 26 millimeter plus minus 1 millimeter. And this 1 millimeter, which is the least count of this ruler, that becomes the minimum error which can be associated with this measurement. If it is clear, please raise your hand. Sujita, you have doubt? If you have doubt, kindly ask. Okay. So least now we go to vernier calipers. So least count of vernier calipers is going to be 0.1 millimeter. Therefore, maximum permissible error is this. So therefore, if it is measured as 26 millimeter by the vernier calipers, so therefore it will be reported as 26 plus minus 0.01 millimeter. Sorry, 0.1 millimeter. Why they have written this? It should be that 0.1. By screw gauge, it will be 26 point plus minus 0.0 millimeter. Okay. Now, vernier scale. What is vernier scale? So it is a scale which is uh, having a main scale here. So this is the main scale. This big scale is the main scale. And this is a movable scale which is known as vernier scale. Okay. So it has a screw, and based upon that screw, this movable vernier scale can go to and fro on the main scale. Okay. Now it has jaws. So this is one jaw. This is the second jaw. So this jaw is used for measuring outer dimension. This jaw is used for measuring inner dimension. And then there is also one small scale. Okay. And this slides outside the main scale, and this is used for measuring the depths. Okay. So this is used for measuring, like outer dimension, inner dimension. Okay. And then, we have the depth also to measure. Okay. Now, how this vernier scale functions? So what happens is, you see, these are vernier scale divisions. Okay. So the vernier scale has vernier scale divisions, and the main scale has the main scale divisions. So now what happens is that n vernier scale divisions coincide with n minus 1 main scale division. Okay. So in this case, there are 10 vernier scale divisions which are equal to 9 main scale divisions. So when this is the case, so then one vernier scale division will be n minus 1 divided by n main scale division, and one main scale division minus one vernier scale division will be 1 by n main scale division. We'll see an example, and that things will become clearer. Okay, so therefore the least count is going to be 1 MSD minus 1 VSD. Okay, this has to be kept in mind. We'll see one example. Okay, like in this case. So we have taken a reading, and in that reading, we got this. Okay, so like these are the jaws. This is one jaw. Okay, and this is another jaw. Okay, so this is the reading which we have got. Now, when we have got this kind of reading, so we have to understand that we have to find out AB. What is AB? That has to be found out. So if we see here, we can write AB as see, till here it's very clear. Till here it's very clear. Okay. But this small portion we don't know. So till here we are very clear that it is 1 centimeter because this is main scale. But this small portion we don't know. So that we have to find out. So now from 1 we see that this particular division coincides with the main scale division. So this vernier scale division and this main scale division are coinciding. So therefore we can write, okay, now this is equal to 5 into vernier scale division, and this is equal to 5 into main scale division. So therefore this small portion will be equal to 5 into main scale division minus 5 into vernier scale division. Okay. Now we find out what is main scale division. So one main scale division is, okay, so there are 10 divisions and 10 divisions make 1 centimeter. So therefore one main scale division is 1 upon 10 centimeter. And we can see that 10 vernier scale divisions coincide with 9 main scale divisions. So therefore one vernier scale division is 9 by 10 main scale division. So therefore this will be 5 into, so now we find out this, 1 MSD minus 1 VSD will be equal to 1 by 10 centimeter minus 9 by 10 centimeter, which is 1 by 10, sorry, not 9 by 10 into main scale division into 1 by 10 centimeter. So this will be equal to 10 divided by 100, 1 by 10 centimeter. Okay, so this is 1 vernier scale is 9 by 10 MSD. So this is 9 by 10 into MSD, which is 0.1 centimeter. Okay. And one main scale division is 1 by 10, which is 0.1 centimeter. So this is 0.09 centimeter. So therefore 0.1 minus 0.09 is equal to 0.01 centimeter. Okay. So 5 into 0.01 centimeter. Okay. So therefore this will be equal to 1 centimeter plus 0.05 centimeter. Okay. Which is equal to 1.05 centimeter. Is it clear? Please raise your hand if it's clear. Please raise your hand if it's clear. Otherwise, I'll explain it again. No issue. So again, just kind of, we understand that the total reading from a vernier caliper will be equal to main scale division plus the n times which the vernier scale division coincides the main scale division into the vernier count, which is 1 main scale division minus 1 vernier scale division. Okay. So in this case also we can see that, you see, till here it's very clear. Till here it is 3.3 centimeter. But this small portion has to be calculated. So we see that 1, 2, 3, 4. The fourth division is coinciding. So therefore 4 main scale divisions minus 4 vernier scale divisions will be equal to this. So therefore 3.3 plus 4 into 1 main scale division minus 1 vernier scale division, which is going to be 3.34 centimeter. Now there is something which is known as zero error. So as we can see here, that the initial zeros of both main scale and the vernier scale, they are coinciding. So therefore there is no zero error. Okay. here the left side we see there is a positive zero error, and then and the right side we see a negative zero error. So what is that zero error? So imagine we go to a grocery shop and we have to buy 1 kg sugar. That is, and this grocery shop has a faulty weighing machine, which initially only it reads, let us say, uh, 0.1 kg. So then what we are going to do? We are going to tell the shopkeeper, fill sugar in the can such that the reading will now be 1.1 kg. Okay, because already in the initial stage it was 0.1 kg. So this is positive zero error. So the length of the object will be whatever is recorded minus the positive zero error. And in case if it was the reading was minus 0.1 kg initially, then the shopkeeper will fill up only till 0.9 kg reading, which makes it 0.9 plus 0.1, which is 1 kg. So therefore, we have to add the negative zero error, whereas we have to subtract the positive zero error. Okay. So positive zero error has to be subtracted, subtracted, and negative will be added to the reading. Okay. Please try to find out this. N divisions of main scale coincide with n plus 1 divisions of vernier scale. So therefore, one vernier scale division is going to be n divided by n plus 1 main scale division. Now each division on main scale is of a units. So therefore, n by n plus 1 multiplied by a. So this is one vernier scale division. So therefore, the least count will be one main scale division minus one vernier scale division, which is going to be a minus n by n plus 1 into a, which is a divided by n plus 1. Is it clear? If yes, please raise it. Keep it in mind that always the least count will be one main scale division minus one vernier scale division. Solve this. Please send me the answers. So, which vernier scale division is coinciding? One, two, three, four, fifth. Okay, keep it in mind. Yes. So let us see. So if we see in this case, this is the zero error. So already, the jaw, both the jaws are not coinciding with each other. Already one jaw is slightly ahead. So therefore, already some reading is taken. And how much is the reading? So if so, since it is the zero of the vernier scale is to right of the zero of the main scale division. So therefore, it's going to be a positive zero error. And how much is the error? So it's going to be 5 into 1 main scale division minus 1 vernier scale division. So simply, so 1 main scale division is 0.1 centimeter. 1 vernier scale division is 9 upon 10 into 0.1 centimeter, which is 0.09 centimeter. So therefore, it's going to be 5 into 0.1 minus 0.09 centimeter, which is 0.05 centimeter. Okay. So that's the a positive zero error, and therefore whatever the reading we'll get, we have to subtract the positive zero error from that. If it's clear, kindly raise your hand. Solve this. Any doubt? Yeah. Okay, so let us first calculate the least count. Least count is 1 main scale division minus 1 vernier scale division, which is 1 millimeter minus 1 vernier scale division. 9 by 10 into 1 millimeter. 1 by 10 into 1 millimeter, which is 0.1 millimeter, which is 0.01 centimeter. Now, while measuring the length of the line, the zero mark of the vernier scale lies between 10.2 and 10.3 centimeter. So that means main scale reading is 10.2 centimeter. And the third division coincides. So therefore, 3 into the least count, which is 0.01 centimeter. So therefore, it becomes 10.23 centimeter, not 22323. So therefore, this is the answer. Any doubt? Please raise your hand. Suchita, any doubt? Yeah. Or no? Okay, if you have understood, please raise your hand. Okay. So this is JEE Mains 2023. Please solve this. Yes, so option B is the correct. Let us see how. Main scale division, like the vernier scale division, coinciding is between 3 point, the vernier scale 0 is lying between 3.2 and 3.3, so therefore 3.2 is guaranteed. This is the main scale reading. So 3.2 centimeter plus fourth division is coinciding, so 4 into 0.01 centimeter, which becomes 3.24 centimeter. So this is the reading, but there is a zero error also, where the zero of the vernier scale lies to the right to the zero of the main scale, and sixth division is coinciding. So therefore 6 into 0.01 centimeter, which is 0.06 centimeter. So 3.24 minus 0.06 is going to be 3.18 centimeter. That's the answer. If it is clear, kindly raise your hand. Okay. That's it. Now we move on to screw gauge. Okay, so screw gauge is relatively simpler. So here, like upon rotation, upon one rotation, the the screw, it moves forward. Okay, so we revolve it from this side, and this scale, that's the circular scale, it also moves towards the left side, left side and right side. Okay, now here it's like very simple, because so in one rotation, the uh, screw, okay, so that moves, okay, that the circular scale that moves one main scale division towards the left. So therefore the least count becomes, okay, the movement in one rotation towards the left divided by the number of divisions on the circular scale. So how much it moves in one complete rotation, that is known as pitch. Okay. Okay, and then the total reading becomes capital N, which is the main scale reading, plus the uh, circular scale reading, which is small n, into least count. Now in this also zero error is there. Here the zero error is little tricky. So of course in the first case it's no zero error. In the second case it is a positive zero error, and already some reading is recorded. In the third case it is a negative zero error, and this is the error. So you see the 46th division is coinciding. So therefore it is a negative 0.004 centimeter. Let us do this together. The pitch of a screw gauge is 1 millimeter, and there are 100 divisions on the circular scale. Okay, so in one full uh, rotation, it moves 1 millimeter. In measuring the diameter of a sphere, there are 6 divisions on the linear scale. Okay, and 40 divisions on the circular scale, which coincide with the reference line. Find the diameter of the sphere. So since there are 6 divisions on the linear scale, so that means it's going to be 6 into 1 millimeter, which is 6 millimeter. And 40 divisions are there on the circular scale. So therefore it is going to be 1 millimeter divided by 100. That's the least count, into 40. So this becomes 0.4 millimeter. So therefore this is 6.4 millimeter. So that's the diameter. Is it clear? If yes, please raise your hand. You could see this. Take your time, see this. If you have understood, kindly raise your hand. Good. Solve this. Yes, we have to multiply the circular scale reading with the least count. So that will give us circular scale reading. And we have to add then multiple the main scale reading. Okay. Let us solve this. Pitch of a screw gauge is 1 millimeter and there are 100 divisions of circular scale. So therefore, the least count is 1 divided by 100, which is 0.01 millimeter. When faces A and B are just touching each without putting anything between, the stud's 32 division of the circular scale coincides with the reference line. They are just touching with the What does it mean 32? 0 is not hidden from the circular scale. Oh, it's mentioned here. 0 of linear scale is not hidden from circular scale when A and B touches each other. Yes. So if we see here, yes. So when this 0 is not hidden, that means the circular scale must have been, somewhere here. So that's why it is a positive 0 error. But if this 0 is scale 0 of the main scale is hidden, then it's going to be a negative 0 error. It will be somewhere like this. So now since it is a positive 0 error, so it's going to be simply 32 into the least count, which is 0.01 millimeter, which is 0.32 millimeter. Now, when a glass plate is placed between the studs, the linear scale reads 4 divisions. So that is 4 millimeter. Circular scale reads 16 divisions. So 16 into 0.01, which is now it becomes 4.16 millimeter. Find the thickness. So 4.16 minus 0.32. This becomes 3.88. No, no, 3.84 centi, 3.84 millimeter. Yes. The bit is clear. Please raise it. How is it positive 0 error? Yes. So if you see in this case, when we rotate it, it's going to kind of, go in this direction. So now when both of them, they are touching each other, and that time this 0 is not hidden, that means there is some positive value or some positive reading is there, because this is the reading actually, this much. So therefore when 0 is not hidden, it's a positive 0 error. But when this 0 of the main scale is hidden, that means that's a negative 0 error. Is it clear? Okay. Solve this. So in a screw gauge, there are 100 divisions in the circular scale. Main scale moves by 0.5 millimeter. So therefore here, the least count is going to be 0.5 divided by 100 millimeters. The zero of the circular scale lies 6 divisions below the line of graduation when the two studs are brought in contact with each other. Okay. So that means there is a zero error, and the zero error is 6 multiplied by 0. Why have I written so much? 0.005. 0.005 millimeter. 0.03 millimeter. That's the zero error. When a wire is placed between the studs, 4 linear scale divisions. That means 4 into pitch, which is 0.5 millimeter. Are clearly visible when the 46th division of the circular scale. So plus 46 into 0.005 millimeter minus 0.03 millimeter. Okay, so that's going to be the answer. So 230, which is 0.23. 4.7 millimeter. 220 millimeter. Oh, I'm very sorry. This is 4 into 0.5. So this is 2 actually. So 2. So this is 2.2. Okay. So this is 2.2 millimeter, which is equal to 220 into 10 to the power minus 2 millimeter. So therefore it's going to be 220. Okay. If it is clear, please raise your hand. Okay. So that's it. We did vernier calipers also. We did screw gauge also. Okay. Wish you all the best. Take care. Bye.